What we're going to do today is we're going to find rational zeros, somewhat according to a rational zero theorem. But what's going to happen today is I'm not going to give you a zero. You're just going to be expected to find all of them. So without any help at all, can you find all the zeros to certain polynomials? This idea is formed from a rational zero theorem. What's going to happen is if I'm given a polynomial and I don't have any set zeros given to me, we're going to look at the constant and look at the factors of the constant to develop a pool of possibilities. So this is what homework looks like. Find the zeros of f of x equal to x cubed plus 2x squared minus 11x minus 12. So if I want to narrow down the possibilities, let's just look at that constant, negative 12. And let's write down all the numbers that could possibly multiply or factors of negative 12. So positive 1, negative 12, or negative 1 and positive 12. So we're going to say plus or minus 1, plus or minus 12, and start filling in the blanks. So all the factors start coming through. And we're realizing plus or minus is very prevalent. And you start picking out of these numbers for possible zeros to do synthetic division. So every single time in synthetic division, you have your setup. And we definitely know in order to get a 0 here, we have to have a 12 here. And good guesses will come from this pool. Start picking numbers out of this pool. So like on the chalkboard, we tested 1, we tested 2, those didn't work, and we realized, okay, let's put in negative 1. This is a guess, and it turned out to be a decent guess. So we start with multiplying and add. Multiply, add. Multiply. It does get you to that positive 12. So we have x squared plus x minus 12, and we're going to figure out what would make that 0. We could either use multiply, add, or quadratic formula. I'm going to just prove to you that quadratic formula would work, since most of you would choose factoring. So in the discriminant, we get a square root of 49, which is good, because if I'm able to factor a trinomial, then these radicals should end up perfectly. Now, two possibilities. Negative 1 plus 7. We're looking at 6 divided by 2, so we either have 3 or negative 4, which is what we would have gotten if we would have factored. Just wanted to prove to you that quadratic formula actually is never failing, whether I can or cannot factor the trinomial. We're going to find the zeros of f of x equaling x cubed minus 3x squared minus 6x plus 8. We look at the constant term, factors of the constant term, to determine what goes in my pool. So 1, 2, 4, and 8, we also need to recognize that negative 1 times negative 8 could also get me a positive 8. So plus or minus on all these numbers. This is the pool I'm going to choose from to try synthetic division for that thing. So 1 is always going to be brought down. Negative 8 has to be in this last spot in order to be a 0. So this will help us kind of guess and move through. So we're going to try positive 2. Multiply and add. Ooh, it didn't work. Because if I multiplied, I'm not going to get negative 8. So backing it up. Or erasing. So positive 2 didn't work. We could try negative 2. See what happens. Multiply, add. Multiply, add. Hey-o! Because 4 times negative 2 does get me negative 8. This bottom portion, 1, negative 5, 4, develops into the trinomial x squared minus 5x plus 4. And we're going to ask ourselves, well, what would make that 0? So we can factor. We've got x minus 1, x minus 4, because what multiplies 4 adds to negative 5 is negative 4 and 1. So wait a second. Notice how we get these other numbers. Wait, so the list, we've got to realize we weren't given a 0 this time. It doesn't say find the other zeros. It says find the zeros. So I need to list them all. -2, 1, and 4 are all the possible zeros, or all the zeros, period. We're going to find the zeros of the function f of x equal to 2x cubed minus 5x squared minus 2x plus 5. So looking at the constant 5, we're going to first try plus or minus 1 plus or minus 5. So I heard somebody try -1, bringing down the 2, and then you multiply, and then you add, and then you multiply, and then you add, and then you multiply. Hey! Yes! So these numbers turn into 2x squared minus 7x plus 5 equals 0. I could either do quadratic formula, or we could try multiply add. So what multiplies to 10 adds to -7 is -5 and -2, but we're dividing by the leading coefficient 2. Because I'm trying to find zeros, technically I don't have to complete bottoms up. I could just realize that 5/2 is going to make this parenthesis 0, and a +1 is going to make this parenthesis 0. So my answers are +5/2, +1, and then the original -1 that I tried from the beginning. I want you to do 3 problems in section 6.6, 32, 36, and 52.